Okay, so we are here with John Cohn, the biggest nerd IBM ever has seen, and also...
I wish that were true.
No, it's really true.
Oh.
And the second thing I notice about John Cohn is that he is a very, very nice person. And
I try.
Yeah.
That's really nice to hear.
Yeah, you're very sympathetic and very helpful to everybody. I think that's the key ingredient in becoming such a successful leader as you are. So we are here at the MIT AI Center, the IBM MIT AI Center. Is that the correct name?
Actually, where we work is the MIT IBM Watson AI Lab, which is quite a mouthful, but it's a wonderful place. But where we're actually sitting today is the MIT campus. We're just off of campus, but actually next year we're moving onto campus. But it's a super exciting place. I think you probably see that too, but we really appreciate you and your other colleagues being here to help us with the hackathon.
Yeah, welcome. So can you tell us about the Satori system? I think that's one of the most interesting assets you have here.
I would love to tell you about the Satori system because it is the coolest thing that I've done in quite a few years. So as all of your listeners, I'm sure, know that AI is getting to be a huge, huge thing. And when I first moved here in the middle of 2018, I continue to live in Vermont, but instead of commuting to Munich, I now commute here to Cambridge. When I showed up at the lab, it was a lot to start learning, to start learning AI, et cetera, because I'm only, when I came in, I had some passing knowledge about AI, much and thanks to you, actually, Romeo. You were the one who got me started. But I've slowly gotten better, and as I've done that, between my own work and other people's work, I notice how important it is to have access to adequate computing, particularly accelerated computing. And it turned out that we just didn't have enough computing, not just in the MIT IBM lab, but across campus. And so I started coming up with this idea of, wouldn't it be great if we could build a Power AI supercomputer here that we could use, that MIT could use for its internal research and its students, as well as some of the stuff that we're doing, the MIT part of it. And so I cooked this scheme up, and then the right alignment of things happened, and all of a sudden it became from a crazy dream to an urgent project. And over the past, say, 7 months, we've been working very hard to design the system, to procure it, to set it up, and now deploy it. And this hackathon that you're helping with, which I really appreciate, is one of our first shakedowns. We have about 163 people who are signed up to use the machine. And but this hackathon is the first time we're actually exercising really large jobs. And it's been super helpful for getting the kinks out.
Awesome. Okay.
I should also note that that is only part of the story. So not only is so Satori is a really interesting machine, and so it has a very interesting name. Satori is a Zen Buddhist word for sudden enlightenment, and it is also let's see, it's the other sock. Hang on, what's that? It is also the name of my younger dog. I have a picture of her, that's why I'm grabbing my socks. My son gave us pictures of our dogs on our socks. So this is Satori.
Oh, okay.
And she's a beautiful 12-year-old Labradoodle. And Satori was walking around while several of us were strategizing about this system. And my boss looked at her and said, "That's a good name for a computer." So here it is. But one of the other things, if I may, just tell you a couple of things about Satori. So it's a 64-node Power AI AC922 system with about, I think it has 260 V100 GPUs. So not the world's biggest machine. It's comfortably in the middle of the top 500 supercomputers in the world. But what's interesting about how we architected it is that it's incredibly energy efficient in terms of flops per watt. And when last year's supercomputer conference was coming up in November, we got notified that our machine was among the top green computers in the world. And we worked very hard to do a bunch of benchmarking on it. This was just the end of October, early November. And at the conference, we learned that we are the fourth greenest computer in the world. And green in that sense meant the most efficient for converting watts into calculations. Interestingly, that of the top 5 of those, of the top 500 greenest, fastest computers, the top 5 greenest, 3 of them happen to be IBM computers, which is pretty interesting because from an architect, I'm a hardware architect, and so that's kind of interesting. The interesting also thing is that our computer, like some of the other MIT hardware clusters, are located in a place called the Mass Green High Performance Data Center, MGHPCC, in Holyoke, Massachusetts, a full 90 miles that way. So speed of light wise, it's a few tens of milliseconds away, which is, tolerable. But that building is a state-of-the-art data center, and it's 97% renewable energy. So not only is this the most efficient, the 4th most efficient green computer in the world, but it's actually in the most efficient data center. So using Satori is an incredibly energy efficient thing. And that is one of the goals of our hackathon, is to start people thinking about the energy needs of AI, because on the path that we're on, especially with a bunch of supervised learning, AI is starting to actually take appreciable energy, and if it continues to grow like this, I think it contributes to all sorts of things, climate problems, etc. So we're trying to breed kind of a responsible way of looking at it. So every time you're going to run something on Satori, it'll tell you how much energy / power you used and how many trees that might be worth.
Okay, that's interesting. And it's better to not even produce the CO2 in contrast to compensate for it.
That's exactly right.
Yeah, and regarding the partnership between IBM and MIT, is there anything else interesting you want to tell us?
Well, the arrangement that we have at the MIT IBM Watson AI Lab is really unique in terms of any academic collaboration that I've ever known with any company. I've been at IBM, almost 39 years. Oh my gosh. But I also, if I include my late father-in-law and my wife, my family has 83 years of IBM, which is something to think about. But what's interesting is when companies, our company or any company, usually works with a university, there's usually an arrangement where you fund some research, you give some money to the researchers, and then in exchange you get access to the IP, or that the IP by mutual agreement is made open, which is a nice thing. This arrangement that our lab has just over 50 projects, and all of them are done jointly, completely jointly with MIT, which means that each of those 50 some odd projects have a lead developer, a lead investigator on the MIT side who's a tenured, who's a full faculty, and then somebody who's a research staff member on our side. So all of the work, all of the code, all of the paper writing is done jointly. So it's not just a financial transaction. Been fantastic. Our small team, we have about 50 people, about 24 of them, I believe, are research staff members, young PhDs. It's just really, really fun to be in an environment like that. Writing, we've been writing tons of papers, doing what we think is really important work, contributing a lot to open work. It's the most exciting job I've ever had, and I've had some good ones.
Yeah, I mean that's very interesting that you are on a system which has GPUs and the fastest CPUs on the planet, plus the fastest interconnect between those two. I think.
Yeah, one thing I just need to be clear is that the Satori system is not while we built it, it was a donation that we did to help support the MIT work, and it's for their use, including our joint work, but they can use it for anything they want. So a lot of the people in there, we have undergraduates, we have all sorts of research projects. So it's not just for use in this collaboration.
I see. Okay, so cool. And regarding your past at IBM, I mean, I've heard you have around 70 patents, is that correct?
Depends on who you count. I have 120 worldwide patents, but yeah, it's and most of those are in the area of my previous jobs, chip design and Internet of Things. But it's fun to try to learn something new. I think this is probably my fourth career, and it's always it's so exciting to just throw yourself in the middle and be knowing that you're the guy who knows the least about stuff is a very good motivator to study hard.
Okay, I mean, I discovered that you actually know quite a lot. You know more than me, I have the feeling.
I don't think so.
Okay, and another question is, so you have worked on chip design before, and now you're seeing the state-of-the-art chip design. How does that relate with all the ASICs coming up with TPUs and TPU units and the GPUs and so on?
You know what I really love about that, Romeo, is that for many years I worked on the software that was used for chip design, and in the course of that, I did mostly the very high performance computers like IBM servers, Z and P series that we call them now. But I also worked for about 8 years on video games, because during the generation of PlayStation 3, Xbox 360, and Nintendo Wii, everybody wanted to build sort of a supercomputer that would fit under the Christmas tree, I guess, the way to think about it. And having those machines were really, really amazing, because the only people who made advanced computers like that were, the other guy didn't want to sell the designs to be customized. We had an engineering customization group, and so we designed those chips for all three of those gaming platforms. What's ironic is that while that was in the late 90s, early to mid 2000s, the work that we were doing then included a bunch of work on graphic acceleration. And if you move forward to, I think it was about 2012, when people realized that GPUs, graphics processing units, could be used to accelerate neural net designs, that's when all of a sudden the AI stuff started to really rise. Machine learning, deep learning, et cetera. That's, we're in the hotbed of that here at MIT. And as graphic accelerators got better, commercial ones or other approaches, and then eventually ASICs like custom things that were designed. And GPUs were never designed to be tensor accelerators, but now many companies, including our own, are working on specialized processors that are more fit to the task. What's really fun for me to think about is that because that acceleration, it came from having fun, it came from gaming or watching videos, and I just love the fact that play and fun kind of recycles to drive technology. That's pretty awesome.
Okay. So if I would have to invest $10,000, would you invest in the latest ASICs for tensor processing, or in phase-changing memory, or in quantum?
What was my investment horizon? It depends, because if I had to vote now, what were the choices again? I think I'd just take $10,000 and go to a nice island somewhere in the Pacific, actually. Was that a choice?
Okay, no. Okay, then just tell me what's the hottest thing in the next, let's say, 10 years? Do you think it's ASICs, TPU processors, phase-changing memory, or...
So I would say that certainly in the next, 3 kind of years, that increasingly specialized accelerators are going to be very, very important. As you kind of hint at, just because of things like the energy, the energy usage of the systems that we do now, if we're really going to change that, you think about, the Satori system is about just under 200 kilowatts, okay, and it is about 1.4 petaflop kind of machine. Okay. Our human brain is like, 20 watts, so there's a lot of room for improvement. And I think that some of the non-digital, I don't think it's not a digital decision. It's instead of using equal width processing, we're looking at more specialized processing that can use different byte widths, various other things, mixed precision to help improve things. But over time, we're going to have to be much more clever about how we do that acceleration. And I think that there's a horizon, it's probably in the 4 or 5 year kind of horizon, where I don't think it'll be across the board, but for specialized applications where power density are really important, that technologies like phase change or analog machine learning will become important, because your brain does it in an analog way, and there's some things that if you can exploit that, analog I'm an analog designer by trade, and there's some messy things about it, but if you can exploit the wonderful physics of analog to your advantage, there's no better way of doing that, something in low power. And you'll probably be trading off performance for low power, but if you have enough of them, then you get the performance at the system scale. So I would put that out at the kind of next generation, and I would say that it'll be a while before that is entirely mainstream, but for edge devices or something where you're very power constrained, it will be there. I think you gave me a horizon of 10 years. That's pretty interesting because I would say that is the horizon where quantum is starting to become very practical, or increasingly practical. I think that within this decade we'll have problems that do yield to the specialized processing of quantum. I mean, it's incredible technology. It's incredibly promising. It's also, we're still a ways away from practical applications in any sort of general way. But I think what you'll see is within this decade, you'll start to see real applications of quantum, quite a few, but it'll be in limited areas, places where you have lots of combinatoric problems, things like quantum chemistry, ironically, and various other things like cryptography, et cetera, or other optimization problems. I think it'll be a while before they're widespread used for generalized programming or AI, but I think that intersection will happen around in somewhere in this decade, which I.
Okay. Yeah. So talking about low energy and low temperature in quantum, we want to talk about high energy as well. Can you tell us where you got your cool Tesla coil from?
Well, as you can tell, I'm a gadget guy.
Okay.
Usually, so I have, which Tesla coil? I have 7 Tesla coils.
Okay, the one I've seen yesterday.
The portable Tesla coil.
Yeah.
Well, I really enjoy making things that are beautiful and cause people to be interested in technology. Maybe even a little, amused by it, maybe sometimes a little scared by it. Always safety first, or as we say in Burning Man, safety third. But Tesla coils and other high voltage things are just sort of a beautiful way of doing something that people don't normally get to see. To see sparks going through the air like this. I have some that go that far.
I think you destroyed your laptop, you said, no?
No, yesterday I did glitch my laptop, but it seemed to come back. But I have destroyed quite a few things with high voltage. And actually the Tesla coil is not the most dangerous thing, but I digress. The Tesla coil that I had yesterday, I didn't build. Many of the devices that I built and like my Tesla coils were built with me or for me by my good friend Scott Fazar, who is actually thinking about him right now. He's undergoing some cancer treatment. And so big shout out to Scott, who's a genius. But this Tesla coil, the one that you saw yesterday, was actually not built by my friend Scott. It was built by my friend Eugene in Kiev. I found this guy on a high voltage forum, and he was a 24-year-old guy who was trying to avoid the draft and was living in his parents' basement and built the world's best Tesla coils for it's a very small wireless Tesla coil, and I've always looked for one that I can take on an airplane. So you never know if you're going to need to pull out a Tesla coil if there are kids around or clients or whatever. And so that one is designed to be taken down and put into a small case that can go in the overhead rack of an airplane.
Oh, okay.
Now, sometimes talking to the security people about what it is, you sort of have to say well, if I were going to make something terribly dangerous, I wouldn't make it look terribly dangerous. And they'll go, that sounds right.
Okay, you're lucky. Then, last question, where are you going for dinner today?
I don't know where we're going for dinner. I can tell you that I am, after 2 full days of hacking, I'm pleasantly sleepy, so I think something that I can eat, and something soft so I can fall asleep in it. I don't know, maybe sushi? What do you think, gentle listener?
Yeah, put it down in the comments. I think
Yes.
sushi is a wonderful idea, and thank you so much, John,
Bye,
for your time.
everybody. Thank you, Romeo. Thank you so much
Thank
for
you.
being here.
Bye.